All right, everyone, welcome back to AI Paper Podcast. Today, we're diving headfirst into a fascinating paper that just dropped. Agentic deep graph reasoning yields self-organizing knowledge networks. I'm stoked to unpack this one. It's got some serious potential to shake things up in the world of knowledge graphs and AI-driven discovery.
Definitely, this paper is a real game changer. It proposes a new AI framework that goes way beyond just building knowledge graphs. This system actually learns and evolves its knowledge base over time. It's like having a superpowered research assistant that can connect the dots, generate new hypotheses, and even ask its own questions, all while constantly refining its understanding.
Okay, so for those of you tuning in for the short form edit, here's the gist. This paper introduces an agentic graph expansion framework that iteratively structures and refines knowledge, merging it into a global graph. The system actively generates new concepts and relationships, formulating subsequent prompts based on its evolving structure. This feedback-driven loop organizes information into a scale-free network, similar to how human knowledge is structured. This demonstrates that agentic, self-reinforcing graph construction can yield open-ended, coherent knowledge structures. Pretty wild stuff, right? Now back to our deep dive.
So what sets this research apart is the concept of agentic deep graph reasoning. It's a radical departure from the traditional static knowledge graphs we're used to. Instead of relying on predefined ontologies or needing constant human supervision, this AI system acts autonomously, driven by its own internal logic and the feedback it receives as the knowledge graph grows and changes.
Yeah, it's like giving the AI the keys to the knowledge kingdom and letting it explore, experiment, and discover on its own. It's a bit like watching a scientific mind in action, wouldn't you say?
Absolutely. And the really exciting part is that this autonomous exploration leads to the creation of self-organizing knowledge networks. The AI doesn't just add information randomly. It forms these intricate structures that resemble real-world knowledge networks, complete with hubs of highly interconnected concepts and bridge nodes that connect different knowledge domains.
This is where it gets really mind-blowing for me. They actually found specific patterns in how these knowledge graphs evolved, almost like a microcosm of scientific discovery in action. For example, they observed these breakthrough phases where the AI's understanding would suddenly leap forward after periods of stability. It makes you wonder what's actually happening in the AI's mind during those moments, right?
Exactly. It raises some profound questions about the nature of learning and discovery, both in AI and in ourselves. And the researchers didn't just stop at observing these patterns, they actually put this AI to the test in a real-world scenario. They challenged it to design impact-resistant materials, which is a pretty tough problem that requires knowledge from a bunch of different fields.
And here's where things get even more interesting. The AI didn't just spit out a list of known materials or regurgitate some textbook solution. It came up with a completely novel design that incorporated carbon nanotubes, self-healing microcapsules, and even smart sensors for real-time optimization. We're talking about a level of creativity and ingenuity that we haven't seen in AI systems before.
This is where the paper starts to get into the technical nitty-gritty. To analyze how the AI achieved this level of problem solving, the researchers delved deep into the algorithms and network metrics used to track the evolution of the knowledge graph. For those of you who are into this kind of stuff, they used a modified transformer model similar to the ones powering large language models, but with a specific focus on symbolic abstraction and reasoning.
And they didn't hold back on the technical details. They provide a thorough breakdown of the knowledge graph's structural properties. Things like clustering coefficients, centrality measures, and shortest path distributions. For those of you who love digging into the nuts and bolts of AI research, this paper is a goldmine.
What I found particularly fascinating was the system's capacity for continuous learning without hitting a plateau. It just kept getting better, constantly refining its understanding and generating new insights. This is absolutely crucial for open-ended scientific discovery. Imagine an AI that never stops learning, never hits a wall. It has the potential to completely revolutionize how we approach research.
And it's not just about accumulating facts. The way the knowledge is organized within the system is also super interesting. It formed these hierarchical structures that showed it wasn't just collecting knowledge, but actually making sense of it, figuring out how all the pieces fit together. Almost like it's building its own internal model of how the world works.
Precisely. The analysis of how the network evolved over time with its shifting connectivity and growing complexity provides compelling evidence of the system's self-regulation and dynamic expansion. It's a beautiful example of how a complex, intelligent system can emerge from a simple set of rules.
Okay, so we've talked about the big picture implications, but I'm really curious about the nuts and bolts of how this AI actually works. How does it go from a prompt like design impact-resistant materials to a groundbreaking solution?
Well, the researchers were kind enough to provide a sort of behind-the-scenes look at the AI's thought process. They started by giving it a prompt, just like you said, and then set it loose in this massive knowledge graph. What happens next is fascinating. The AI starts exploring different nodes and connections, almost like a researcher browsing through a library, pulling books off the shelves, following citations, and piecing together clues.
But it's not just randomly browsing, right? It's using what it's already learned to guide its search, zeroing in on the most promising areas. It's not like a detective following a trail of evidence.
Exactly. And as it explores, it's not just passively absorbing information, it's actively reasoning about what it finds, analyzing relationships, synthesizing new ideas, and even identifying potential contradictions or gaps in its own knowledge. This is where the recursive nature of the system comes in.
Oh, interesting. So as it generates these new insights, it feeds them back into the knowledge graph, effectively teaching itself and opening up new avenues for exploration.
Right. It's like a self-reinforcing learning loop. Each new discovery fuels further exploration and deeper understanding. This feedback mechanism is crucial for enabling the AI to build on its own discoveries, refine its hypotheses, and progressively move towards more sophisticated solutions.
So after many iterations of this explore, reason, refine cycle, the AI lands on this novel material design. And the researchers walk us through the entire thought process, highlighting the key connections that led to this breakthrough.
What's remarkable is that the AI didn't just combine existing ideas, it actually came up with something genuinely new. It pulled together elements from materials science, nanotechnology, and even a bit of biomimicry in a way that nobody had ever thought of before. This is a powerful example of how this system can generate truly innovative solutions that go beyond simply rearranging existing knowledge.
This is what gets me so excited about this research. It's not just about building a smarter AI, it's about using AI to push the boundaries of human ingenuity and potentially solve problems that have stumped us for centuries.
Absolutely. To really understand how this all works, the researchers did some seriously in-depth graph analysis. They tracked how the knowledge graph evolved over time, looking at how the AI's exploration patterns and reasoning strategies changed as it learned. They went way beyond simple metrics like the number of nodes and edges. They dove into the network's structural properties, things like clustering coefficients, centrality measures, shortest path distributions, to uncover the hidden dynamics of this self-organizing knowledge system.
Okay, so for those of us who aren't graph theory experts, can you break that down a bit? What were some of the key takeaways from this analysis?
Well, one thing they found was that the knowledge graph didn't just grow randomly. It developed these hierarchical structures with certain concepts emerging as central hubs and others acting as bridges between different domains. This mirrors how human knowledge is often organized with core concepts and interdisciplinary connections.
So the AI is essentially building its own internal model of how knowledge is structured, which is pretty amazing.
Exactly. And they also observed how the distribution of information flow within the graph changed over time. Initially, a few dominant nodes controlled most of the knowledge transfer. But as the AI learned, the network became more decentralized with multiple pathways for knowledge dissemination.
That's interesting. So it's like the AI's thinking is becoming more flexible and interconnected as it explores the knowledge landscape.
Precisely. It's a fascinating glimpse into the emergence of a more nuanced and sophisticated understanding.
Now, all of this sounds incredibly promising, but I'm sure there are still challenges to overcome. What are some of the limitations of this system?
Well, the researchers acknowledge that there's still work to be done in terms of scalability and interpretability. Scaling this up to handle truly massive knowledge domains is a significant hurdle, and interpretability is crucial. We need to be able to understand how the AI is arriving at its conclusions, especially when it's coming up with novel solutions that we've never seen before.
Yeah, that makes sense. We don't want these systems to become black boxes that we can't understand or trust.
Exactly. But even with these challenges, the potential of this technology is undeniable. We're talking about AI that could revolutionize scientific research, accelerate discovery, and maybe even help us solve some of humanity's grand challenges.
So let's get back to the graph analysis. You mentioned some specific metrics they used. Can you give some concrete examples of what they found and what those findings tell us about the AI's learning process?
Sure. One of the metrics they looked at was Betweenness Centrality. This basically measures how often a particular node in the graph lies on the shortest path between other nodes. In simpler terms, it tells us which nodes act as key connectors or bridges facilitating information flow within the network.
So a node with high betweenness centrality would be a sort of information hub, right?
Exactly. And what they found was fascinating. In the early stages of the AI's learning, a few dominant nodes controlled most of the information flow. But as the knowledge graph expanded and the AI gained more sophisticated understanding, the betweenness centrality became more evenly distributed across the network.
So it's moving away from relying on a few central concepts and towards a more decentralized, interconnected model of knowledge. Kind of like how a student might progress from rote memorization to a deeper, more conceptual understanding.
That's a great analogy. Another intriguing analysis that they did involved looking at the longest, shortest path within the knowledge graph. Now, this might sound a bit counterintuitive, but stay with me here.
Okay, I'm intrigued. What's so special about the longest, shortest path?
Well, it essentially tells you how far apart the two most distant concepts in the graph are. By analyzing this path, the researchers could get a sense of how the AI was connecting seemingly disparate areas of knowledge.
So it's like a measure of the AI's ability to make connections between seemingly unrelated ideas.
Precisely. And what they found was that the longest, shortest path often involved these fascinating and sometimes unexpected leaps across different domains, highlighting the AI's ability to synthesize new insights by connecting seemingly unrelated concepts.
That's really cool. So it's not just connecting dots, it's making those creative leaps that often lead to breakthroughs in scientific discovery.
Exactly. And they took it a step further. They actually challenged the AI to come up with a novel scientific discovery based on the concepts and relationships it had uncovered along this longest, shortest path.
Okay, so they gave the AI a kind of creative challenge based on its own exploration of the knowledge graph. What happened?
Well, the AI didn't disappoint. It proposed this entirely new paradigm for designing materials inspired by biology, integrating concepts from fields like microfluidics, biomimicry, and even artificial intelligence itself.
Wow, that's impressive. So this isn't just about organizing knowledge, it's about using that knowledge to generate genuinely new and creative ideas. This is what makes this research so groundbreaking.
Absolutely. It opens up a whole new world of possibilities for AI-driven scientific discovery.
It really feels like this research is pointing towards this idea of AI as not just this like tool, but like a real collaborator in scientific discovery. It's almost like we're seeing the birth of like a whole new type of scientific intelligence, one that can like work with us to uncover this new knowledge and solve these like really complex problems.
Yeah, it's an incredibly exciting idea. And while this research is still early, it has the potential to like completely change how we approach scientific inquiry. Imagine a future where these AI systems can just go through huge amounts of data and identify these patterns and generate hypotheses and even design experiments, all while working together with human researchers.
Yeah, that's like the dream, right? To have these AI partners that can help us see connections we might have missed and challenge our assumptions and like push us to think in these new ways. It's like having this team of brilliant, tireless research assistants that just work all the time.
Exactly. But of course, like with any powerful technology, there are these important ethical considerations to address. We need to make sure that these AI systems are developed and used responsibly in a way that aligns with, human values and goals.
Absolutely. Transparency, fairness, and accountability are like super important. We need to understand how these systems work, how they make decisions, and what potential biases they might have. It's crucial to have these conversations now while the technology is still evolving.
Yeah, I totally agree. And it's not just about preventing potential harms. It's also about making sure that the benefits of this technology are shared fairly. We need to make sure that access to these powerful AI tools isn't limited to just a few people, but is available to researchers and innovators all over the world.
That's a really important point. Like democratizing access to these tools could have a huge impact on scientific progress, especially in fields that are like currently under-resourced or overlooked. It could like even the playing field and give power to researchers from all different backgrounds to make these groundbreaking discoveries.
Exactly. Now, one thing that really stood out to me in this paper was its emphasis on symbolic abstraction and reasoning. This is a bit different from many current AI approaches that rely a lot on statistical pattern recognition.
Yeah, this feels like a more human-like approach to AI, focusing on understanding concepts and relationships instead of just, crunching numbers.
Yeah.
Can you talk a little more about why this is important and how it helps the system's ability to come up with creative solutions?
Sure. So symbolic abstraction is basically the ability to represent these complex concepts using symbols and rules. This lets the AI reason about things in a more abstract way to make generalizations and to take knowledge from one area and apply it to another. It's like a key part of creativity because it lets the AI break free from the limits of its training data and come up with totally new ideas.
So it's not just about memorizing facts, it's about understanding the underlying principles and using them in different situations.
Exactly. And the researchers showed that their system could do this really well. For example, in that impact-resistant material design challenge, the AI was able to pull from knowledge in biology, physics, and engineering to come up with a solution that combined ideas from all these different areas.
That's a great example of how symbolic reasoning can lead to really innovative solutions. It's like the AI can see the world in a new way, connecting ideas that a human might never have thought to put together.
Exactly. And this opens up these exciting possibilities for using this technology to solve other complex problems that need creativity and interdisciplinary thinking, like things like climate change mitigation, drug discovery, or designing these sustainable cities.
It's mind-blowing to think about the impact this kind of AI could have on so many areas.
Yeah.
It feels like we're at the beginning of this new era of scientific discovery where AI plays a big role in pushing the boundaries of human knowledge.
I totally agree. And I think this paper gives us a good plan for how we can get there. It shows how important it is to develop AI systems that are not just intelligent, but also creative, collaborative, and ethical.
Yeah, those are some great words to end on. A big thank you to our expert for breaking down this amazing paper and for sharing your thoughts with us. And to all our listeners, thanks for joining us on this deep dive into AI and knowledge graphs. We'll put links to the paper and some other resources in the show notes. Until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible with AI.